Okay. We are now broadcasting. All right. So first of all, the homework, I guess. Were there any big questions on the homework? I mean, the prep work, I mean.
No, I worked through that one thing I was asking you guys about with the new formulas and all that. And interesting in some of the stuff, though. You know, the instructor,
Yeah.
if you watch the video, he wasn't rounding out all the way. And then he's like, well, that little difference is not that big of a deal. But then he explained that the test will accept if you're off on those, hundreds and thousands, by so far because rounding. So that was kind of interesting.
That's cool. Okay, so should we go ahead and try to do the...
Yeah, let's jump right into the
then?
quiz because we only got
ready to do that.
this hour to do it.
Okay. Okay. Bring up the test. Okay. Meeting quiz. Okay, you guys got it open?
Yeah.
Okay, cool.
Yep.
Okay. T-distribution applet. In previous lessons, we had assumed the population standard deviation was known. In this lesson, we are making a different assumption about that. What has changed? It's unknown.
Yeah, unknown. First one.
Definitely when it's always one. Wouldn't that be nice?
And the number 4 is kind of related.
Yeah, number 4 is. It tells you right. It's funny. Some of these tell you that the deviation is not known. Is the deviation known? No.
Yeah.
With the value of t. So for that, we need the applet, right?
No. That one you do the t
equals
the population, or the x minus the population mean divided by the standard deviation divided by the square root of n.
Right.
So you had to do, yeah, it's all given up there. The population mean is 8, x is 11, standard sample 6. So I came up with 1.5. So I got 11 minus 8 divided by 6, or divided by the square root of 9.
The 1.5, you said?
That's what I came up with.
Yeah, I just came up with the same.
I love it when the quizzes say round to like 1 decimal, and that's all you came up with. It makes you feel more confident.
Yeah, I agree.
So the answer is you get 1?
1.5.
Oh, right. Wait. $11 minus 8, right?
Yep.
Which gives you 3.
Yes.
You're dividing that by 3, right? Because n is 9.
You're dividing it, by 2, because it's 6 divided by the square root of 9, which is...
Right. Okay, yeah. Okay. Let's write it down. So... 1.5. Okay. So for this one, we just need to copy and
So
paste.
for the next one, yeah, well, unfortunately, it
information
doesn't
into
let you copy and paste out of quizzes. So I already keyed these in to the quantitative descriptive statistics, and our
Okay.
mean is 98.22 using that sheet.
Okay.
And it says the 3 decimal places. Is that
Yeah, but it came out to flat out 98.22 on the formula.
all right? Perfect. All right. I
Okay.
trust that.
I hope
We'll know if it's wrong. We'll be able to.
Yeah.
Yeah.
That's a pretty simple computation if we need to do it.
Okay.
And then S is that? I guess that's the sample
That's
standard deviation.
Sample
mean.
sample mean.
Standard
Yeah, because
deviation.
the other one's the population mean. So S is the sample. Actually, the sample standard deviation.
Yeah.
Right.
Sample standard deviation.
And so it should give you that too in that same first.
Yes, it does. So that standard deviation is 0.922.
Okay. And then the t-score. So to get the t-score, you have to put in the other information too. You have to put in. Let me pull it up. You need to put in
Yeah,
the
the T is going the T is going to be the.
So you need to put in the null hypothesis and the confidence level, which the null hypothesis is the 8, right? Or no, I'm looking at the wrong
98.6.
98.6.
98.6.
Yeah.
Yes. So that's your null hypothesis. And then
98.6 is our population mean, which is the same as null hypothesis.
there's our level of significance.
And then we got our X, which is 98.22, minus the population mean of 98.6, divided by our S, which is 0.922, divided by the square root of our sample size, our N.
Is that 20? Like, is that the sample size?
20. There's 20 up there, correct. What, 92? I got a negative 1.843.
Okay.
I had a 3.007 for the t-score.
All right, so 0.922 divided by the square root of 20. .206. Okay, so then 98.22 minus 90.6.
Wait, what was the sample mean?
The sample mean is 0.922. That's the S.
Wait, so no, that's
Nope.
that's the sample deviation. What was the sample mean?
The sample mean is our 98 point. Okay, so the which one? The sample means the x, correct?
Yeah, right.
98.22. So you're
Okay,
gonna have
that
a
was my
negative
fault.
number.
I put 99.22. So
Okay.
maybe
Yeah, because it's gonna be a negative number because it's 98.22.
Yeah, okay.
98.6.
So now I've got negative 1.843.
There you go.
That's what I got. Okay.
All right. Thanks for helping me clear that up. That's
Oh.
good.
No problem. We're all in this together, man. Now we got to open up the thing to get the p-value.
Right.
The p-value, that's going to be the shaded area in the middle. Or am I in the
Yes.
wrong thing here for the template?
Yeah, the p-value.
We use the template for that, right? The probability.
You can. It also gives it to you if you use the Excel sheet they gave us. You can also get it from there.
That's the second Excel sheet, correct?
Yes.
All right. So
The
then
quantitative inference procedures.
we got to rekey all those numbers in there. I can copy them from the one sheet.
Oh wait, were you using the other sheet for those first two? Because you're supposed to be using this one the whole time.
Oh, I've been using another sheet, even in the
Oh.
other one.
Okay.
All right. Well, it still gives us the same. The mean is 98.2. The
Right.
standard.
That should be the same.
Yeah, it's all the same.
Yeah. That should all be the same. But it will also give you the t value and the p value. Although you need to put in your confidence level and
Yeah.
your null
What's our
hypothesis.
What's our confidence level?
And that, I'm not sure if we have it.
0.05. All right. Wait, the A is the confidence level, right? Level of confidence is that little A? Significance. No, that's level of significance.
Level of significance.
That's not
Yeah.
right.
Confidence level is usually a percentage. It's like the 95%
Yeah.
or 90%.
Give us our confidence level.
Yeah. So we'll have to.
Or do we use that out of the, do we have to pull that out of that probability applet?
Do we need the confidence level for the p-value?
In the applet, it wants it.
I want
But-
it. Okay.
But when you're doing it by yourself,
Well,
that's the thing. I did the homework and
Doesn't the applet give it to us? Well, okay, there we go. Yeah, here it is. You go into the applet, the degrees of freedom. That's what the, no, that's not what the little thing is either. Crud. Hold on. I'm thinking wrong.
let me see if that even. Oh no, that doesn't affect it. That's right. You can ignore that. The confidence level is for calculating the confidence interval.
Yeah. So we should.
So the T and the D. So if you put anything in the confidence level and you put in the null hypothesis and the type of test, I don't think fix it either. Yeah, as long as you have the null hypothesis in, the T and DF aren't affected by the confidence level or the null hypothesis.
All right. And our null hypothesis.
Or I mean, it is affected by the null hypothesis, but it's not affected by the type of test and the confidence level.
All right, so all we need to do is put the null hypotheses in, and that p-value
And
that's
the
in
variables, and it'll give us and that p-value should be correct.
Okay, so that says 0.9595. So 0.96. Are we rounding to just two numbers?
Let's see. No, 2, 3.
3. Okay, so it's going to be 0.9595. So it's actually 0.96, correct?
Yes.
0.9595 would round us up to 0.960.
Yes.
0.96.
What is the correct decision based on this evidence?
Well, the p-value is much higher than the little a of 0.5. So it's high, so we fail to reject, correct?
Right.
If it's low, we reject. So if it's high, we fail to reject.
Right. Because there's a good.
All right. I'm still on number 9 here. I'm trying to wrap my head. It's again trying to figure out how to get the p-value.
Let me share my screen.
Okay.
See the.
Yeah.
Give me a second. Let me get that. Okay.
All right. So here's. You guys seeing the screen?
Yeah. Yeah.
All right. So here's the template. Here's all the 20 variables. Here's where we got our mean or standard deviation. So I had to put the null hypotheses up here in 98.6.
Okay.
Correct, Michael?
Yes.
And then that gives us the p-value, regardless of what our confidence level is.
All right. It also gives us,
I'm sorry. Where's that pop out? Oh, I see right there. Okay.
Right there at the
yeah.
bottom.
It also gives us the t value, which
Yep.
you could actually check that against what we wrote down, and it should be the same.
Yeah.
All right. So p-value is 0.95.
Well, we're going to 9595 rounds to 0.96 when you go 3 decimals.
Yeah. Okay.
Yeah. So it's just like plug and play.
Not so 0.956.
Yep. I know,
Yeah.
0.960.
Oh, 60. Got it.
0.96. Well, just 0.96. You don't even put the 0 on there. So that, again, will fail to reject because the p-value is higher than the A, which is the what does that A stand for?
The level of significance.
Level of significance. That's correct. Level of
Yeah.
significance.
That seems like a super high p-value.
It does, but again, we can check everything that's in here, and all our numbers have matched up so far.
Okay.
So
All right. So we're gonna fail to reject.
yeah, because the confidence level doesn't affect it or anything. So fail to reject it.
Yeah.
All right.
I've noticed in most cases, either like it's the p-value is usually never like right close to the 0.05, or it's either like way big or way small in most cases. Okay, so we got our baby boom values. Okay, so this is the same kind of things. We're just
Wait
using
time
the
between
top one
minutes.
again.
Average time between birth is 40 minutes. So our little level of significance is very small, 0.01. So now we got to put all these numbers in again.
Yeah.
Yep,
Be nice if we could copy and paste.
I'm gonna put them in myself this time too.
We have 24 sample size.
Yes.
null hypothesis is 40.
I
Not
I
equal
see
to.
21 numbers. Did you say 24 sample size?
Oh, hold on. You're right. It's because that starts at 5. So,
Okay.
Yeah. Yeah, it's 21.
21.
Okay. So the p-value I got from it. Is all right.
0.99. 0.995.
Oh wait, I have to change my null hypothesis.
Yep. Null hypothesis is 40.
.498.
No,
Is that what you have?
no, I got 0.995. What do you have? What is your mean? What was your mean, Michael?
40.048.
Yeah, so was mine.
Okay. And then your null hypothesis is 40, right?
So
Yeah.
is somebody's sample? Did they put in the right n?
Yeah, it's calculated automatically. As
Oh,
20.
it doesn't automatically.
Yeah.
Yeah.
Where would the difference
Up
be?
here under, if you're on my screen, variable 1 n is 21.
Yeah.
You can see. Can you see my screen, Paul?
Yeah, I sure can. Yeah.
Yeah, it's right here. N is 21. Then our mean is the same at 40.048. So, Michael, what's different on R2 that's making your p-value much lower than mine?
Let me see.
Because the confidence level makes no difference in the p-value,
All right.
whether it's equal to, greater than, or whatever. Oh, you know what? Change yours to not equal to. That's the difference. Because our null hypothesis is not equal to the type of test we're running. That makes a difference.
That does make a difference.
Now
Okay.
are you 0.995?
Yes.
Okay.
And I'm correct considering our alternate hypothesis is not equal to. That's what we got to run, right?
Right.
Type of
That's
test
correct.
we're doing.
That's the way it was worded.
Okay.
Okay.
And then our level of
Oh,
significance
on
is
the last
0.01.
one, did you check that too, Rick?
On which one?
So when we were getting the p-score, p-value for question 9,
Yes. What?
you had that set to less than.
You know
or
what? I
greater
think
than, mean.
I think I had it on greater than.
Okay. Okay, that should be right.
I know it wasn't on not equal to. I know that for a fact.
Okay. If it was on greater than, then it was fine.
Okay. Yeah, because I just changed it to not equal to for this one. Again, we're going to fail to reject because the level significance is 0.01.
Right. Yeah.
This is much higher.
I agree with that. Okay, so this is number 13 is a good question because now we're switching it to less than 40.
Right, and so the p-value should decrease. And if we change it, it decreases, yeah.
Correct.
But does it decrease enough? Probably not.
No, it still doesn't decrease to
Okay, so we're still going to fail to reject.
correct.
Oh,
It
sorry,
drops
on the next question. I was like,
yeah, it drops it to 0.50 is all. We're still going to fail to reject.
yeah.
You know, Michael, I'm glad we're doing this and I was on this call because I wasn't using that tool correctly and I was working through a bunch of math problems the hard way to answer these things. So this is going to help me a lot.
No, I actually already took the homework quiz, and I mean that's pretty much what you do is you just plug into the applet.
Nice.
It gives you stuff.
All right, so now we have to construct a 95% confidence interval for the true mean wait time. So, do we do that in the template here too, Michael? Yeah, we do.
So
So 95.
which,
So what type of test are we using on this one?
I think we're still the not equals.
Not equal to? Okay.
I think so.
It looks like our confidence level interval doesn't change regardless of what type
Right.
of test it is.
So
So
the
my-
lower limit is 23.499, right? Or
That's what
0.5.
I'm showing.
3.5 because it says round to 1.
This round of 1. All right, so 23.5.
Then the next one's 56.
Paul, are you seeing that on
6.
the? Yeah. Do you have the? I don't know if you have the template open, but we're looking at the confidence level
So
down
my
here.
question is, it says construct a 95% confidence interval. Do we have to do anything in the applet to do that, or?
No, you just have to make
so there's
sure
a-
your confidence level up here in this
Okay.
tool is 0.95. And then, like I said, in this case, it doesn't matter if we're not equal to or greater
Okay.
than. It only affects the p-value.
I
Then
see
it gives
that.
us our confidence interval. Man, this would have saved me a ton of time had I known how to use this thing right, doing the pre-work and stuff like that.
Yeah. Well, that's what, because when I took the homework quiz, it doesn't even like give you the link to the T probability thing,
Yeah.
applet. It gives you the link to the other applet, which is not that useful, but
Yeah. And
Right,
I'm gonna,
we haven't even really used that in this
No.
quiz.
and I'm
Yeah.
gonna submit here, guys, first this time, and hopefully it says 100%.
yeah.
That'd be nice.
Scroll down. Oh, we missed 2.
Uh-oh.
All right, so we missed questions number 9 and 10. That's our p-value. So we did something wrong there.
So maybe that was the one where we didn't have the right.
Yeah, I may not have had the correct thing in there.
Okay.
I just probably a word for it, but
Let me. I think I can just hit the back button and
Yeah.
hit back.
well,
quality
we just
sign
do
or
this-
type of test.
Think about that till afterwards.
I'm just hitting the back button on my Excel.
Yeah, so this should be
There we
less
go.
than, right?
Yeah, that changes the p-value to 0.04 if you go
Well,
less.
It should be
Yeah, it's less than.
less than.
Okay,
Yep.
0.04.
Yeah, how many decimals does it want on that one?
3.
Number 9 said 3 decimals, so it changes to 0.04. Yeah, well, it'll round up to 0.041 is what it'll be, and then that's the case. We will reject the null
Reject.
hypotheses.
I mean, it's the only option left.
Yeah.
Okay.
That was definitely our mistake because the answer above that is correct. So
Yeah. So I'll go ahead and submit real quick. We just missed those 2, right?
Yep.
Yeah.
Whoa, 100%.
Did you put for number 9 0.040 or 0.041?
0.041.
Yeah, 0.041.
Okay.
All right, you're gonna have to read me the answers off here really quick again.
All right.
Okay, come on.
When you're ready.
All right, question 1, true.
Number 2 is false.
Very funny, Michael.
Um,
Number 3 is we assume it's unknown.
assume it's unknown. Number 4 is no.
Hey,
There's
can
no-
you hold on for a second? I must have put in one wrong. I put in.
Okay.
I'll just reload real fast.
Yep.
I
Yep.
shall wait. I'm gonna stop our recording because